So what is continuous random variable, right? A variable x which can take any value in an interval, not just whole number, but it can take any number, right? Suppose for height, weight or time, right? It is not like discrete random variable like coin flips, right? It has infinite possible values, infinite possible values, right? So this is what continuous random variable, right? So suppose I am having a density curve, right? So area under that density curve will give me probability area under density curve, right? Suppose I am having a probability density curve and fx should be greater than or equal to 0 for all x, right? And total area under curve should be equal to 1, right? So it should be given as minus infinity to infinity fx dx is equal to 1, right? So if my fx is a valid probability distribution function, so it should be minus infinity to plus infinity fx dx integration will be equal to 1. So suppose there is a question, find k such that fx is valid p probability distribution function, right? And fx is equal to kx square if x belongs to 1 to 3, right? So here I will be having integration 1 to 3, right? fx dx, that is kx square dx, and this will give me what is equal to 1. So it will be kx cube by 3, 1 to 3 will give me 1. So it will be k is equal to 3 by 26, right? Now I have cumulative distribution function, right? Suppose fx, right, this is fx and this is probability of random variable x less than or equal to any given value, right? It gives probability that random variable x is less than or equal to the given some value it is having, right? Total of the area under probability density function, right? So fx is equal to integration minus infinite to infinite, right? Sorry, minus infinite to x at given value, and then it will be ft dt, right? And then from getting probability density function to cumulative density function, right? Sorry, cumulative distribution function, probability distribution function to cumulative distribution function, I should integrate, right? Integrate fx, and from getting cumulative distribution function to probability distribution function, I have to differentiate capital Fx, right? Now probability of any value a and random variable x up to b is given as f of b minus f of a, and if it is asked at any point x is equal to a, so probability will be 0, right? And that probability will be equal to 0. Now what is mean? Mean is expected value, so it is equal to minus infinite to infinite x f of x, right? F of x, then here's dx, and then variance tell how values are spread out from mean, so it will be defined as minus infinite to infinite x minus mu square, right? Fx dx, so it will be given as e of x square minus mu square, right? Now let me erase this. We will discuss a question. So let's discuss a question now. I have question given as fx is equal to e to the power minus x by 4, where x is greater than or equal to 0. So I am having fx, let me erase this again. Yes, I am having fx, right, is equal to e to the power minus x by 4, this by 4, where x is equal to greater than or equal to 0. So I am having mean as integration of 0 to infinite x e to the power minus x by 4, and this is 4, right? So I will do here by parts. So I will write this as x, then differentiate, and it will be written as minus e to the power minus x by 4. This will be written as minus 4 e to the power minus x by 4, and this will be again differentiated as 16 e to the power minus x by 4, and this plus and this minus, right? So it will be minus x 4 e to the power minus x by 4, and then plus 16 e to the power minus x by 4, right? This whole by 4, 0 to infinite. So 0 to infinite, this will give me 0, and this will give me at infinite it will give me 0, at 0 it will give me 16 by 4. This will be equal to what? This will be equal to 4, right? I got 4. Similarly, for e x square, right, it will be given as 0 to infinite x square fx dx. So similarly, we can also find this, and then for variance, I will do what? E x square minus mu square, right? Now, let's now discuss about gamma function and Gaussian integral, right? So gamma function is defined as gamma of n is equal to 0 to infinite e to the power minus x, x to the power n minus 1 dx, right? And Gaussian integral is defined as minus infinite to infinite e to the power minus x square dx is equal to root pi 0 to infinite e to the power minus x square dx is equal to root pi by 2, right? And then normal distribution bell curve. A continuous random variable is normal when its probability distribution function is famous bell curve formula, that is fx is equal to 1 by sigma root 2 pi and e to the power half. This is x minus mu, which is mean, divided by sigma and this whole square, right? Any normal random variable x can be converted to a standard normal z, right, where mu is equal to 0 and variance is equal to 1, right? So z is equal to x minus mu by sigma, right? So let's do a derivation related to it. Suppose I have to prove my mean value, right? So how can I prove? Let me show you. Let me erase this. So Suppose I have mu is equal to here integration minus infinite to plus infinite fx dx. So it will be given as minus infinite to infinite x, right, 1 by sigma root 2 pi and then e to the power minus 1 by 2 x minus mu by sigma square, right, and then dx. So I take my x minus mu by sigma is equal to z. So x is equal to mu plus sigma z. So dx is equal to sigma dz, right. So it will be written as 1 by sigma root 2 pi and then minus infinite to plus infinite mu plus sigma z multiply e to the power minus z square by 2, right, dz into sigma, right, and then this will be further written as 1 by root 2 pi integration minus infinite to infinite u e to the power minus z square by 2 dz plus 1 by root 2 pi minus infinite plus infinite sigma z e to the power minus z square by 2 into dz, right. So this is what? This is an even function. So this will be equal to 0 and this will be equal to mu by root 2 pi into what I will write? 2 0 to infinite e to the power minus z square by 2 dz, right, and this will give me what? This will give me right, this will give me pi by root pi by 2, root pi by 2, right. So ultimately this will give me mu because here it is root cancelling. So root pi will get cancelled, root 2 will get cancelled and ultimately I will get mu, right. So this was all for this video.